Now we consider a numerical question in the topic of refraction of light. Refraction of light, we are going to take up a numerical problem. The problem reads like this: a fish is at a depth d underwater. Take the index of refraction of water as 4/3. Show that when the fish is viewed at an angle of refraction theta 1, theta sub 1, the apparent depth z of the fish is z is equal to 3d cos theta 1 divided by root 7 plus 9 cos squared theta 1. Apparent depth. Okay, we see how to solve the sum. Say there is a fish here, angle of refraction theta 1, okay, fish. F represents fish, A, B, C. So fish will be observed to be here at the position of A, and say real depth, it's given to be D. This is the apparent depth, let's say Z, apparent depth Z. When you are viewing from here, you have to prove the apparent depth Z is given by the formula 3d cos theta 1 divided by root of 7 plus 9 cos squared theta 1. The person is viewing from here, so apparent depth is this, real depth is this, and how do you connect all these things? That is the question. Understood that? See here, you know that mu is equal to generally sin I by sin R. If mu is the refractive index of the second medium with respect to the first medium, here we are discussing about the refractive index, say, of the first medium as mu. Refractive index of the first medium with respect to the second medium we take as mu, which will sin R by, which will be sin R by sin I, but here sin theta 1 by sin I. This is I, the ray goes this way. Now we can see if this is I, this is also I, alternate angle. This is theta 1 means this is also theta 1, corresponding angles. You will have to produce this refracted ray backward. Another ray may come this way. The two rays will intersect at position A, which is the apparent location of the fish. So geometrically what you can do, draw a vertical line. Okay. Then produce this refracted ray backward, point of intersection A gives you the apparent location of the fish. So sin theta 1 by sin I, so sin theta 1 opposite by adjacent, I call this as x. X by AB, AB is hypotenuse, but you see in this thing there is no hypotenuse. There is no way hypotenuse may come here. There is real depth, there is angle of refraction, apparent depth. So instead of the hypotenuse, use Pythagoras theorem z square plus x squared square root. Sin theta 1 is x by AB, but AB is root of z squared plus x squared. Then similarly sin I here, x by, this time the hypotenuse is FB, but you can write it as d square, d is here, d square plus x squared square root, d square plus x square square root. Therefore this mu, finally you can substitute for mu. Okay, mu is sin theta 1, so x by root of z square plus x square into sin I, take it to that side, numerator, d square plus x square by x. Cancel out this x. You have root of d square plus x squared by root of z square plus x squared. So squaring both sides, you will have mu square is equal to d square plus x square by z square plus x squared. Okay, right? Yeah. Now again I have to remove this x square somehow from the expression, and also I have to bring in cos theta 1 or cos square theta 1, anything. So what you can do here, let this be this, cos theta 1 is equal to AC, which is z, by cos theta 1, no, AB, which is again root of z square plus x square. So what you can now do, squaring both sides, cos square theta 1 is equal to z square by z square plus x square. So for the z square plus x square you can substitute in terms of cos square theta 1. So this you will get as mu square is equal to d square plus x square by, for z square plus x square you use this, which will be z square here, cos square theta 1 will be in the numerator. Expand, d square cos square theta 1 plus x square cos square theta 1 whole divided by z square. Now again I have to somehow remove the x square. So what you can do, x square cos square theta 1 is there, no? That you can get from this. So you want, you can call this as equation 1. So from equation 1 you have cos square theta 1 z square plus cos square theta 1 into x square, or I will write the other way around, easy, z square cos square theta 1 plus x square cos square theta 1 is equal to z square. Now substitute for x square cos square theta 1 and eliminate for z, you will get the answer. Substitute for mu also. So how will you proceed further? Okay, this you got, you have to substitute for x square cos square theta 1. On the left you have mu square. So mu square is equal to d square cos square theta 1 plus x square cos square theta 1, which will be z square minus z square cos square theta 1 whole divided by z square. Now you see mu you can substitute as 4 by 3, d real depth, z apparent depth, theta 1 angle of refraction. So you have to solve for z square, eliminate for z, you will get the answer. We will just see how to eliminate for that. Mu square z square, take this to the left side, mu square z square is equal to d square cos square theta 1 plus z square minus z square cos square theta 1. You want to get z square. So take the z square terms to the left side, mu square z square, or you can straight away write, you can skip one step, z square into mu square. This will come to left side, that will become minus z square is outside, so minus 1. Then this will become plus, so plus cos square theta 1 is equal to d square cos square theta 1. Yeah. So I just remove this. So z square is d square cos square theta 1 by mu square minus 1. I'm going to write this, mu square minus 1 plus cos square theta 1. Don't forget that mu is 4 by 3. Mu is 4 by 3. Substitute, simplify. So z square is, let me remove this also, z square is equal to d square cos square theta 1 on the numerator. This is 16 by 9, mu is 4 by 3. 16 by 9 minus 1 plus cos square theta 1 is equal to d square cos square theta 1 by 16 by 9 minus 1, 7 by 9. So 7 by 9 plus cos square theta 1. Therefore z square is 9d square cos square theta 1 by, right here, 7 plus 9 cos square theta 1. But what we want? Simply z. Look at this. Therefore you get z as square root of the whole thing. So numerator you will have 3d cos theta 1 by square root of 7 plus 9 cos squared theta 1. Is also z, is also z. So 3d cos theta 1 by root of 7 plus 9 cos square theta 1. Hence we have proved it. Okay. Now we will check whether this is applicable for near normal viewing. Suppose you see from the vertically downward direction. Under limiting case, make theta 1 0. Suppose under limiting case z will be cos 0 is 1, so 3d divided by root plus root of 7 plus 9. Okay, so 3d by root 16 is 4. Therefore mu is real depth by apparent depth. We will just see whether real depth by apparent depth gives mu. This is apparent depth. So mu is, real depth is d, apparent depth is z, which is 3d by 4, so it will go here. Mu is 4 by 3. So this also gives you the quantities when you view the fish in a near normal direction.